Welcome to Kanerika's podcast, The Digital Shift. I'm really excited for today's session because we are tackling a problem that feels, well, incredibly high stakes. We are talking about the unseen infrastructure of healthcare, not the surgical robots or the new drugs, but the absolute mountain of data that it generates every single second. I mean, we're talking x-rays, lab results, billing codes, doctor's notes, wearable telemetry. It is just massive.
It is massive, and it's growing exponentially. But the issue we face in the industry isn't just the volume, it's the Tower of Babel problem.
Yeah.
Generally speaking, none of these high-tech systems actually talk to one another.
And that is the core friction point we need to dismantle today. We have all this information, but it's fragmented, almost by design.
That's a good way to put it.
You have electronic health records sitting in one silo, PCS imaging systems in another, and then, billing and claims data locked away in a totally separate financial database. It feels like we are trying to treat a patient by looking through 5 different keyholes, but nobody can open the door to see the whole room.
That is unfortunately a very accurate description of the status quo. We call it fragmentation by design. It wasn't malicious. These systems were just built for specific isolated functions. But the result is this incomplete picture.
Right.
Imagine a specialist trying to make a critical diagnosis. They have the clinical chart, but maybe they don't see the full historical context because it's trapped in some legacy archive. Or they miss social factors affecting the patient because that's in a public health data set somewhere else.
Which is terrifying.
I mean, we aren't just talking about operational inefficiencies or losing money, though we will get to that. We are talking about decisions that impact human lives being made on partial information.
Precisely. And that brings us to the solution we are unpacking today, Microsoft Fabric for Healthcare and Life Sciences.
Now, Fabric is a buzzword we hear a lot in the data space, but for the healthcare leaders listening, is this just another data warehouse, or are we talking about something more? A fundamental shift in architecture. It's a fundamental shift. Think of it less as a storage unit and more as a unification engine. The whole mission of this discussion is to explore how we break down those silos, not by building more bridges, but by, changing the foundation itself. It's about shifting from just managing files to actually generating insights.
Okay, let's get technical then. Usually, when you try to unify data, you have to build these expensive, brittle ETL pipelines, extract, transform, load. You're moving data from system A to system B, and half the time it breaks. How does Fabric solve the physics of moving that much data?
The short answer is you stop moving it. The core innovation here is OneLake.
OneLake. Okay.
Okay.
Implicitly, that suggests a single repository.
Yeah.
But how does that work physically across different clouds and different formats?
This is where the concept of shortcuts comes in, which is a total game changer. In the traditional model, if you wanted to analyze data, you had to copy it. You'd copy it from the source, move it to a staging area, then to a warehouse. Every single copy creates latency, it increases storage costs, and it introduces security risks. Which version is the truth?
All right, you end up with data final v2.csv, and nobody knows if it's accurate.
Exactly. With OneLake, you virtualize the data, so the data stays where it is, whether it's in Azure, AWS, or on-prem. But OneLake creates a logical map to it. It's like moving from everyone having their own locked filing cabinet to everyone working from a single shared digital library. The file doesn't move, but the access becomes universal.
Okay, so that solves the access problem, but it doesn't solve the messiness problem. Healthcare data is notoriously dirty. You have HL7 messages, unstructured text, JSON blobs. If you just virtualize access to all that chaos, don't you just create a data swamp?
You would, absolutely, if you didn't have a rigid governance structure. That is where the Medallion architecture comes in. It's a framework for refining that raw data into wisdom.
Let's walk through the layers, because I think this is where the real engineering happens. We start with bronze.
Yes, the bronze layer is your landing zone. This is the raw dump. It's the unchanging record of truth. We ingest the HL7 messages, the original CSVs, the messy IoT data right here. Crucially, we do not touch or edit this data.
Because you need an audit trail. If there's a legal question 3 years from now, you need to be able to show exactly what the machine spit out, warts and all.
Precisely. It's all about compliance and lineage. Then we move to the silver layer.
The cleanup crew.
The cleanup crew. That's perfect. This is where we run our pipelines to deduplicate records, handle missing values, and harmonize patient IDs. This is where we ensure that J. Smith in the lab system is recognized as the same person as John Smith in the billing system.
Which is historically a complete nightmare in healthcare.
Oh, it's the biggest headache we face in informatics. But once that is resolved in silver, we move to the gold layer. This is business ready. This is the highly structured aggregated data that feeds your Power BI dashboards and your AI models. By the time data reaches gold, it is trusted, compliant, and optimized for read speed.
So it's a refinement plant. Crude oil enters at bronze, high-octane fuel exits at gold.
That's the perfect analogy. And because this is all happening inside one environment, the security governance applies to the entire pipeline.
I want to pivot to the specific capabilities because the material we reviewed highlights some data types that usually break standard SQL databases. We aren't just talking about rows and columns here.
No, not at all. And that's why this is specifically for healthcare and life sciences. One of the biggest breakthroughs is with imaging, specifically DICOM data.
For our listeners who deal with PATS systems, they know DICOM is heavy. It's pixel data plus metadata. And historically, that lives on a completely separate island from the clinical text.
Exactly, and that separation limits diagnosis. Fabric allows us to ingest that DICOM metadata directly into the data lake. This means a clinician could run a query that links a visual lung scan feature directly with a trend in historical lab results. You are querying the image context alongside the blood work.
That connects the visual to the clinical, but there's also the contextual piece, the why. I'm really interested in the SDOH integration.
Social determinants of health. This is where we start treating the person, not just the pathology. Fabric can ingest public datasets about community risks, things like housing stability, food security, pollution levels.
This is so critical for population health. A provider might see a patient continuously readmitted for asthma. Biologically, they're being treated correctly. But if the data shows they live in a ZIP code with high particulate matter and poor housing stock, the fix isn't a different pill, is it?
It changes the entire treatment plan. You might connect them with a social worker instead of just upping the dosage. Fabric brings that external socioeconomic data right alongside the internal clinical charts.
There's one more technical piece I want to touch on before we get to implementation. Conversational data. Doctors are burning out because they spend half their day just typing notes.
This is where the DAX Copilot integration really shines. It stands for Dragon Ambient Experience. It ingests audio and transcripts from patient-provider conversations, but it doesn't just store the MP3 file. It turns that spoken voice into structured, analyzable data about workflow and documentation quality.
So it's transforming unstructured audio into metadata we can actually query.
Yes. It can identify patterns in patient interactions or flag where documentation might be vague. It turns the black box of the exam room into an actionable data source.
That leads me to the research side. We saw the acronym OMOP in the notes. For the researchers listening, why does this matter?
OMOP stands for Observational Medical Outcomes Partnership. It sounds academic, but the problem it solves is incredibly practical. Every hospital records data slightly differently. If you want to do a multi-site study on a new cancer drug, you usually spend the first 6 months just agreeing on what column name equals diagnosis.
You're mapping schemas manually. It's a huge time sink.
Right. OMOP is a standardized common data model. Fabric has pipelines that can automatically map data to this standard. It lets different hospitals compare drug exposures and disease progression instantly. It accelerates research timelines by months.
Okay, we've established the what and the why. It's impressive. But I'm putting myself in the shoes of a CIO listening to this. They are looking at their 20-year-old legacy stacked Crystal reports, on-prem SQL servers, maybe some old Tableau dashboards, and thinking, this sounds great, but I cannot rewrite 20 years of logic.
That is the migration paralysis. Implementation is usually where these digital transformation dreams go to die.
And this is where we need to shift perspectives, because we aren't just commentators here. At Kanerika, we are in the trenches doing this work. So when we walk into a client site, how do we tackle that mountain of legacy debt?
Well, speaking from our experience at Kanerika, we know that manual rebuilding is a trap. If you try to manually recode thousands of reports, you will run out of budget before you even finish.
So we automate it.
We have to.
Right.
We use specific migration accelerators. We have developed tools that can actually read the logic inside legacy Crystal reports or SSRS and automate the migration to Microsoft Power BI and Fabric.
So that's a key distinction. We aren't just moving the data, we're translating the business logic.
Correct. And we utilize our F-Live platform. It's a low-code, no-code data ops platform that automates the data pipelines. It handles the heavy lifting of moving and transforming the data so that our human experts can focus on the strategy and the architecture.
Then that ties into our philosophy. We talk a lot at Kanerika about not just being pipe builders.
Absolutely. We shape solutions around business needs. We don't just say, here's your data lake, good luck. We ask, Do you need real-time decision-making for the ICU? Or do you need massive retrospective analysis for billing? The architecture, how we set up those medallion layers, depends entirely on the answer.
Let's talk about results, because when organizations actually bite the bullet and partner with us to do this, the impact is measurable. Let's look at the clinical side first.
Clinical decision support is the holy grail here. Let's take sepsis detection. Sepsis is a silent killer. It moves so fast. If you catch it an hour late, mortality spikes drastically.
And the signs are usually subtle and scattered. A slight fever recorded by a nurse, a lab result an hour later. It's hard to connect those dots manually.
Exactly. With Fabric's real-time capabilities, we can analyze streaming data from bedside devices alongside incoming lab results. We can set up logic that triggers alarms before a patient crashes, not after. The system connects the dots that a human might miss in a busy shift.
That is literally life-saving.
Yeah.
But what about the operational side? Hospitals are massive logistical machines.
They are. Think about bed occupancy, supply chain usage, emergency department wait times. We call this real-time intelligence. If a hospital administrator is looking at a report from yesterday, it's useless for solving a bottleneck in the ER right now. Fabric processes streaming data so they know exactly where the pressure points are this second.
And then there's the financial backbone, the revenue cycle.
This is where accuracy pays off. It's about catching errors before they leave the building. If we can match the clinical context to the billing codes before submission to an insurer, we can dramatically reduce claim denials. It ensures the hospital actually gets paid for the work it does.
We have some specific case studies from our work at Kanerika that put real numbers to these concepts. I want to highlight the pharma client we worked with.
Yes, this was a major organization struggling with those exact legacy tools we mentioned, crystal reports, slow Tableau extracts. Their data handling costs were just skyrocketing, and the reporting was weeks behind.
So we came in with the automated migration to Fabric and Power BI. What was the fallout?
The results were striking. We saw 71% higher reporting accuracy.
71%. That implies they were operating with a significant amount of bad data before.
They were making decisions based on best guesses. We also saw 38% lower data handling costs. But the metric that really matters for pharma is speed. 64% faster decision-making. In drug development, time is patent life. Speed is everything.
We also have a healthcare provider case study, a hospital system, dealing with those fragmented clinical and billing systems.
Correct. There, we implemented AI-powered analytics and workflow automation. The headline was a 50% faster invoice processing time.
That's cash flow velocity.
It is, and a 25% improvement in operational efficiency. When you free up a quarter of your operational capacity, that is time and resources that can be redirected to patient care, which is the whole point.
There's also an industry benchmark worth mentioning from Microsoft's partner ecosystem, specifically EPM.
Yes, they reported a 40% reduction in implementation time and costs when using Fabric's pre-built healthcare solutions compared to building from scratch. It just validates that the platform approach is simply faster than bespoke engineering.
I want to look toward the horizon for a minute. We talked about fixing the present, but AI is moving so fast. How does Fabric position these organizations for the future? I'm seeing some names in our notes. Alan, DocGPT, Mike, Susan. These aren't new employees, are they?
No, they aren't people. These are specialized AI agents, essentially agentic AI workflows that can be deployed within this ecosystem.
Let's break down the tech behind them. What does Alan actually do?
So Alan is an AI agent built to summarize complex legal documents. In healthcare, you are drowning in vendor contracts, compliance paperwork. Alan uses large language models to digest those documents and extract key terms instantly.
And DocGPT. I assume that's a retrieval augmented generation tool.
Exactly. It's a document intelligence agent. So instead of searching a file directory, you ask DocGPT, what is the protocol for pediatric sepsis established in 2024? It retrieves the specific document and the specific paragraph.
Mike is listed as the math whiz.
Mike is designed to catch arithmetic errors in financial reporting. LLMs are notoriously bad at math. Mike is a specialized agent that verifies the numbers in billing reports.
And finally, Susan.
Susan is perhaps the most critical for our discussion today. She is an automated redaction agent. She scans documents and automatically redacts PII, personal identifiable information.
Which brings us to the elephant in the room. Security. You cannot have a conversation about healthcare data without talking about HIPAA and governance.
Absolutely not. In this industry, security isn't a feature, it's the foundation. The beauty of the Fabric ecosystem is that compliance is baked in from the start. It has IPR and GDPR readiness out of the box.
And that's managed through Microsoft Purview, right?
Correct. Purview provides that data governance layer. It allows for granular line-by-line security and masking. We can control exactly who sees what. A researcher might see the trend data for a study, but the patient names are masked, while the attending physician sees the full record. It ensures we can innovate without compromising patient trust.
So if we synthesize all of this, we've covered the fragmentation problem, the OneLake virtualization solution, the incredible capabilities from imaging to SDOH, and how we at Kanerika use automation to actually get clients onto this platform.
We have, and I think the big takeaway is that we are witnessing a fundamental shift. We're moving from an era of data holding, where we just stored things in the basement and hoped we could find them later, to an era of data acting.
Data acting. I like that phrase.
The convergence of clinical, operational, and financial data is the new standard. If you aren't doing this, you are flying blind in at least one eye.
And that is exactly where we come in. Just to reiterate for our listeners, we at Kanerika are a Microsoft data and AI solutions partner. We live and breathe this stuff.
We do, and our message to the industry is simple. Don't let the legacy debt scare you. If you want to accelerate your data transformation, partner with us. We modernize enterprise operations not just by installing software, but by understanding the business need behind the data.
So if you are listening and you are tired of the silos, reach out to us. We have the accelerators to make the move painless.
Absolutely. The tools are ready.
I want to leave our listeners with a final thought to chew on. We've talked about what the tech can do today, but I want to pose a question to everyone listening, specifically the leaders.
Go for it.
If your healthcare data could talk to your operational data in real time today, what life-saving insight would it reveal tomorrow that you are currently missing?
That is a question every leader needs to be asking themselves.
Thanks for listening to Kanerika's The Digital Shift. We'll catch you on the next one.